for the new guidance document. A couple weeks ago, we had one that was more roadway focused, and we talked about design example 1. Design example 3 is for the larger skew bridges where there's square up panels, and as a result, the bridge engineer needs to be engaged to put together the reinforcing list for the more complicated approach panels. So hopefully you can see my screen, and we will just dig into it here right away. So I'll go over a little bit of an introduction and the need for the new standard plans. We'll talk about functions of an approach panel, and it seems kind of basic for most bridge engineers, and it is, but there's a lot of interaction and coordination that needs to take place, and so we'll talk about that. We'll spend a minute or two talking about how the new standard plans were developed and where the input was sought. And then we'll step through each of the 19 new standard plan sheets. And so there are 3 subsets of standard plans. One set of drawings for 0-degree skew bridges, another set of plans for small degree skews under 15 degrees, and then lastly, there's a set of drawings for larger skews. We'll spend a little bit of time talking about why a guidance document makes some sense. We'll briefly skim through what's in the guidance document and the appendices. And because this is focused on a bridge audience, we'll talk about the approach panel layout memo. And so the approach panel layout memo is something new that's used to help coordinate bridge elements with the roadway elements at the approach panel here. And then we'll step through design example 3 quickly to give you an idea what's included there. So first, a little bit of nomenclature. I'm guessing most people are familiar with what an approach panel is, but we're talking about sort of the golden colored concrete slab here that rests on the fill below. It rests on the sill on one end and the bridge abutment on the other. And so if we take a look from the top and look down, we have our bridge in blue. It's got a pretty good skew in this example. We've got our roadway pavement in blue on the left and right. We've got shoulders that are in sort of a pinkish color. And then our approach panel shown here in the golden color. And because the skew is over that 15-degree magic limit, we are showing it with a square up panel as well. And so what's shown in gold here is an approach panel in MnDOT. So the last major update to the standard plans was in 2016. And as of a couple of years ago, the drawings had morphed into a collection of details that were getting a bit more difficult to assemble and required quite a bit of tailoring. And so in the example you see off to the right, you can see details are crossed out. You can see paragraphs are crossed out. New language is inserted in boxes. And it just was time for a fresh set of standards to come on the scene. So this chunk of concrete with reinforcing in it, we're going to ask it to do several things. We're going to ask it to carry vehicular loads from the roadway pavement to the bridge and back to the roadway section. We're going to have a design that hopefully minimizes the bump at the end of the bridge. We want to carry our drainage off the bridge into a drainage feature or a drainage system associated with the roadway system. We need to accommodate the horizontal movements that are anticipated at the end of the approach panel. And we'll talk quite a bit about that because it depends on what kind of bridge you have. The approach panel also is a location where the end posts for a barrier or parapet are often located. And so structurally it needs to support those elements. And if we have sidewalks and medians and elements like that, we need to transition from the bridge section to the roadway section. So let's step through each of these guys one at a time. It needs to carry the vehicular traffic from the bridge to the roadway pavement. And you see the truck here coming off the bridge, trying to get to the roadway section. and there might be a small void. And I know in other states, there are sort of design spans for approach panels. That's not the case here at MnDOT. There is no custom design. The designs have a prescribed amount of reinforcement in them, and the reinforcement is slightly more than what it was in previous standards. And so that's task one for our approach panel. Task two is to provide as a transition element between our bridge on the right, which is likely founded on piling and not moving up and down, and our roadway section on the left, which may be consolidating a bit after construction. It might be moving up and down a little bit with seasonal changes in the embankment and subgrade. Another thing we'd like to do is to convey the water that falls onto the bridge, off the bridge, and so it needs to come through the approach panel and make its way to the roadway beyond to a drainage feature or a drainage system element off the end of the approach panel. This one's a little trickier, but you guys are bridge guys in large part, so it shouldn't be too much of a lift here. And so our bridges are expanding and contracting with temperature changes. And so as it gets colder, the bridge shortens. And as it gets warmer, the bridge lengthens. And depending on how the joints are detailed and the abutments are detailed, the demand on the sill joint at the ends of the bridge may be modest or minor, or they might be more substantial. And so we'll talk about different bridge types here real quickly to talk about those thermal movements. But before we do that, we need to talk about the three different types of abutments that MnDOT has or typically has on their bridges. On the left, you see a picture of an integral abutment, and that's characterized by a single row of piling, and that piling is assumed to flex back and forth with temperature changes. Parapet abutments are not assumed to move at all. They have multiple lines of piling underneath them, and there typically is an expansion joint at the top of the deck near the back wall of the abutment, and so no movement is anticipated there. All that temperature change for the bridge is taken up in that red element. Then a hybrid is the semi-integral abutment, which has multiple rows of pile on the bottom, and it has at least a hinge joint in the middle, or it may have a sliding joint in the middle. And so there's two flavors of semi-integral abutments. So if we look at these different types of bridges and try to compute the amount of movement needed at our sill joints, it's going to vary with the type of abutment. So integral abutments would be assumed to have oftentimes a point of fixity right in the middle of the bridge. And so our length for thermal movements would be half the bridge length for this case, plus the length of the approach panel would be the amount of structure shrinking and expanding with temperature effects. For parapet abutments, the demands often are less because we have the joints over the parapet abutment that takes care of the bridge shrinking and expanding, and all we have to accommodate at the end of the approach panel are the concrete panel itself, the length of the approach panel. So it's often shorter than an integral bridge. And for semi-integral abutment bridges, we often have one fixed bearing and one expansion bearing. And so on the left, you can see that the length that needs to be accommodated by that sill joint is just the approach panel, like a parapet abutment. And over on the right, you can see that the sill joint needs to take the entire length of the bridge span plus the approach panel length. And so it's actually more demanding from a movement perspective than an integral abutment bridge. And one just note for background information for you guys is that The joint size that we're detailing to go over the sill assumes there is no bituminous pavement movement towards the bridge. If we have concrete pavement, it's been assumed that there is up to a ½ inch of concrete pavement movement towards the joint, and that the rest of the movement is coming from the bridge itself. So to start the coordination process between bridge designers and roadway designers, we need to put together what will be called the approach panel layout memo. And key to that will be telling the roadway people what type of abutment is used, what type of sill should be used, and what type of joint. And so in the past, it's usually been an E8 joint, which is 4 inches wide. Now there's an option to have no expansion joint at the end of the approach panel for short lengths and bituminous roadways. Or there could be an E5 joint, which is 2½ inches wide, or the 4-inch joint, which has been used historically. And so the table you see on the right is in the guidance document. And so this is what the bridge designer would look at to put together the design memo. You look at the type of pavement, the type of abutment, the length of the movement or expansion length going on, and then he'd pick a sill detail and a size of expansion joint. We'll talk about these more later. So as mentioned, one of the other tasks for our approach panels is to anchor and guardrail and end blocks for barriers and parapets, and to serve as a transition from our bridge section to our roadway section. And here you can see a sidewalk carried from the bridge to the roadway section. So Paul and Braden worked really hard to get input from a number of different stakeholders to put together the new standard plans. There was input from district road designers, district construction, maintenance group, foundations unit, concrete unit, central office standards, the bridge office, and consultants. And so in a nutshell, the layouts for the standard plans are larger than they were in the past. There are a number of 3D isometric drawings as well to help visualize some of the geometry changes going on. For bridges with skews under 15 degrees, it's a simplified bill of reinforcement. And so that is really simple and straightforward. For the larger skews, the bridge designer needs to work on the reinforcement schedule for that. And the new guidance document has 3 fully detailed examples that include pay items and quantities. So the new standard plans went live on MnDOT's website April 30th of this year. They are in 5-297.223 through 228. And it should be noted that 222 is retired and that these numbers do not align with the old standard plans. So they've been modified and updated. So as mentioned, they're in 223 through 228. Of the 19 standard figures or plans, only 8 to 10 of them will typically be used on a typical bridge. And off to the right, you can see one of the tables that's in the guidance document, and it shows all 19 sheets. And it's got 3 columns off to the right. And so the minty green colored column are the sheets you would typically need to put together approach panel drawings for a 0 skew bridge. If you've got a skew under 15 degrees, you would use the blue column, and for larger skews, the gold color off to the right. Roadway designers are going to be responsible for assembling the plan sheets. There was input that construction would like things packaged in AP1 through APX subsets or sets of sheets, but that is not a requirement. They can be integrated with the other standard plans if it makes sense for that project. So the roadway designer will certify the layout sheet, and the bridge designer will certify the larger skew reinforcement sheet. All other sheets, unless they're modified for some reason, should not need certification. So here's the first 5 sheets in the 223 series. You can see in gold what is the approach panel for modest skews and zero skew bridges. On the right, you can see for the larger skews, there is a square up panel included. And so for people trying to figure out what's a left-hand skew and a right-hand skew, if you sit at the start of the bridge and look up station, it's the hand you swing back to point to the abutment is the one. So it's a hand backwards orientation. In addition to the larger layouts, there are other additions. There's a transverse section added to the left side of these. And then there are 3 tables added to the middle, and those describe the type of abutments, the type of sill to use, and the size of joint. And so the roadway designer will get the bridge abutment and sill type information from the bridge designer. And so here's what those tables look like. You specify for each abutment whether it's a parapet or an integral or semi-integral abutment. You specify whether it has an A, B, or C sill detail. We'll talk about those in a bit. And then which type of joint is sitting at the end of the approach panel. It can be none for type C sills, or it could be an E5 or an E8 joint. Another thing that's sort of unique to MnDOT is what's called a Davidson detail, and that impacts where the start of the approach panel is. And so in a typical parapet abutment, which you see on the left, it has what's called an end block sitting on top of the abutment back wall. And that's to facilitate replacement of the joint if needed in the future. And so that's the end block option. On the right, you see the Davidson detail, which shows the approach panel resting on top of it and slightly cantilevering over the edge of the back wall. And so this is important for computing quantities and knowing where the start of the approach panel is. So square up panels are required on skews exceeding 15 degrees. And the skewed portion of the approach panel must maintain a minimum length of 15 feet. And so that means if you have a skew over 41.5 degrees, you'll have a length along your gutter line that's longer than 20 feet to accommodate, to make sure you have 15 feet normal to that joint. After the layout sheet, sheet 6 of 6 is included, and this is basically the barrier end transition details. And so there are 2 sets in here, one for single slope barriers and another for parapet details. And the offsets that you see on the top here differ between the 2 different systems. And so that's why they are carried forward in a lot of these isometric drawings. So this sheet will typically not require certification. So that's the end of the layout sheets. And so you basically pick 1 of 6, or you pick 2 of 6, or 3 of 6, or 4 of 6, or 5 of 6, and you add in 6 of 6 at the end. So bridge designers will need to coordinate information through this approach panel layout memo that we'll talk about shortly. So inside the guidance document, we have each of the 19 sheets presented, and we have highlighted where people need to annotate sheets, and the colors of the annotation indicate who's responsible for the information. So here's the layout sheet for a larger skew bridge, and you can see there are a bunch of green clouds and a bunch of blue clouds. Information coming from the bridge designer is highlighted in the green clouds. Information the roadway guys have is in the blue clouds. And so this is certified by the roadway guys. And then on the bottom, you can see that we have a bridge number spot, and the project numbers and sheet numbers need to be added. So here's in general, what the approach panel layout memo looks like. It's a 2-page document that on the first page describes the abutment type, the sill type, and the joint size. And on the right side, on the second page, is a number of geometric stations and elevations. And it also coordinates pay items. So if there are barriers on the approach panel, it identifies what pay items, barrier steel, barrier concrete, that's going to be captured in the bridge pay items. And so this should go to the roadway designer at the 60% bridge plan submittal is the goal. So the reinforcement sheets have been tailored to the same subsets we've been talking about so far. There's one for a 0-degree skew bridge. There are a couple of reinforcing sheets for small skew bridges, and then there are 3 sheets for the larger skew bridges. And so there are formulas near the table that the contractor's fabricator will use to produce the reinforcing list for the small skew bridges. So all that needs to happen on these sheets for small skews is that the sheet number and project numbers get annotated to it. And it should be noted that the bottom longitudinal bars used to be a number 6 bar. They've been bumped up to a number 7 bar on these sheets. There are also a couple other changes. The hook bar or the tie bar that would keep the approach panel from shifting off to the roadway side of the world has been changed from a straight development bar in the middle of the panel to a hook. And so this was to facilitate compaction equipment getting closer to the back wall and improving the compaction under the approach panel. So for the larger skews, you need to pick either sheet 4 or sheet 5, and then sheet 6 will be the sister sheet to go with it. The reinforcement needs to be completed by a bridge engineer or bridge designer. We've got series bars in this makeup panel or square up panel, if you will. And the bottom longitudinal bars have been increased to a number 8 bar, and they used to be a number 6. And so this sheet will need to get certified by the bridge engineer after it gets populated and updated with the project information. And so the sister sheet shows the additional bars that are in that square up panel, and those bars are shown on this sheet. And if you need to add lap bars, there's no need to update this sheet to update the callouts for the additional bars. This sheet will typically only have project numbers and sheet numbers added to it. So as mentioned earlier, depending on your skew, pick the appropriate reinforcing sheet. If you've got the larger skew, the bridge engineer needs to produce that sheet for the plan set. There are some changes in the sill details from what you've seen in the past. The sill will now be held back 1 foot from the end of the approach panel. This is intended to provide space for the drainage elements to drop down out of the joint without going beyond the end of the bridge. And so there are 3 sill options. Option A over here is for concrete pavement. And so the sill has bars that are cast into the roadway section, and the E-joint is put in place on top of it. If you have bituminous main line and an E-joint, you will have a concrete header sitting on top of the sill, and that will be to receive the E-joint sitting on top of that. And what takes a little getting used to, but makes more sense the more you think about it, is option C for our low movement situations where we have bituminous pavement approaching the roadway. And so the bill of reinforcement for the sills can be really simplified as well, because our sills will never be oriented at an angle more than 15 degrees. And so there are formulas that the contractor's fabricator can use to produce those sheets as well, or reinforcing schedules, if you will. So here's sill option A in a little larger format. You can see we've got concrete roadway, we've got our tie bars, and we've got our longitudinal bars that are called out in our sill option as well. And we've got an E joint, E5 or E8, sitting on top of that. The old drainage pipes were a 4-inch diameter pipe that were embedded in the detail. This has been dropped to a 2-inch diameter pipe to provide a pipe that fits inside that E5 joint. So sill option B is shown here. We've got bituminous main line. So we have to add the concrete header on top of the sill to be the other side of the E joint. The bill of reinforcement is simplified as well. And here's sill option C. So there is a drainage pipe underneath the end of the approach panel. There is no joint, so there is no pipe inside the joint itself and no sill. So there are options, or there are likely cases where you will encounter concrete mainline and bituminous shoulders, and you may be enticed to try to simplify things and put an E5 joint at the edges and an E8 joint in the middle. Resist that temptation. Put the E8 joint all the way across or the E5 joint all the way across. So the sill options are included for all projects that use option A or B. Certification typically is not needed. You just need to indicate on the 223 layout sheet what type of option is being used for the bridge project. We go to the joint details themselves. Paul and Braden worked up some really nice isometrics to help illustrate where the sill elements are for the different combinations of curb and barrier and parapet on different sides of the joint. You should note that the L joints and the C joints have been moved to the 226 sheets. So they were not here in the past. They have moved here for the future. And there are a couple more options to be displayed here. And so sheet 2 of 3 gives you additional details on what can happen at the sill details for the bridge. But if you don't have any of these details in your project, say your end post terminates earlier and you don't have a transition right at the joint, this sheet can be omitted from your plan set. This is the joint details sheet, and so it shows a number of things. It shows the turn-ups inside the curbs, inside the barriers, inside the parapets, intended to keep that roadway or bridge drainage going over the approach panel back to the roadway. If we don't have these turn-up details, the water just decides it wants to make a nice right-hand turn and exit, and we get issues of erosion out the side of the bridge. And so it's important to keep these turn-up details in the joint. Cover plates are now provided for the joint on the outer face to keep debris from entering the joint from the side. We no longer need to add one for the curbs. If you've got a type C sill detail, you don't need this sheet at all. So basically, all you need to do for the design process is make sure you have the right boxes checked on the layout sheet on that front sheet that gets certified. So these later sheets do not require certification. 227 is a 1 or 2 sheet section of the new standards, and it's intended to describe where the C and the L joints will be placed. So these are the additional contraction and longitudinal joints between the different concrete pours. And so if you have a wider bridge, you may need to customize this sheet and certify it. But for standard 2-lane bridges, the goal is that this sheet won't need to be modified. You can use it as it is. For the larger skew bridges, it is recommended that the roadway designer check in with the concrete unit for questions on preferences for the additional C and L joints. And as the skews get longer, these square up panels get longer, and it probably makes sense to start adding in additional transverse joints. And so that's part of the reason for that conversation with the concrete unit. But again, unless it gets tailored or updated, there is no need to certify this sheet. And so the design process is simply select the appropriate sheet. And if you've got a high degree skew, have a conversation with the concrete unit. And the last sheet is the drainage layout sheet, and it's intended to convey to the contractor that the piping that's in the E joint or underneath the end of the approach panel needs to be connected to a drainage feature or the drainage system on the roadway side of the world. So why develop a guidance document? I guess it seems like it's got a number of positive benefits, including consistency of design. It hopefully is a tool to bring new staff up to speed on the expectations and preferences MnDOT has for approach panels. And it's a good vehicle just to make sure, because we've got a lot of disciplines involved, from roadway to bridge, construction, and the concrete unit. And so what I'd like to do next is just step into the guidance document, scroll through it, and give you an idea of what's in the document itself. And so hopefully I can do my transition here without too much pain. And I'm going to scroll through this pretty quick because there's a lot to talk about yet. And we've already been here half an hour. So table of contents is pretty straightforward. List of figures. We've tried to add a lot of figures to help explain the expectations. Got some tables. We've got a short introduction, and that reinforces some of the lingo we talked about earlier in the presentation here about what's a approach panel, what's a square up panel, different types of abutments. So on the right, we've got the integral abutments, and we've got parapet abutments, and we've got the semi-integral abutment described here as well. After the introduction, MnDOT's been using approach panel since 1945. So Mr. Rokamp dug up all of MnDOT's records pertaining to approach panels, And it's a 275-page document that's the appendices that are nearly complete here. But if you've got an older project with older approach panels in it, Paul's put together a nice piece of work to help you understand what may be incorporated into the bridge you're working on. So more there. Then we've got what we call the 5-step process to assemble the approach panel plans. And so it's trying to just describe quickly each of those 5 steps. And the biggest one is coordinating the information for the layout sheet. And so step 1 for a roadway designer is to review what the bridge designer has sent him as part of the approach panel layout memo. And so here's a sample layout memo that we talked about already. Here's the table that we mentioned that describes what the bridge designer will use to select an appropriate sill type based on pavement, an abutment type, and expansion length. So we talk about that a bit. We talk about the 19 different standard plans. We've got the 3 different groups for zero skew, small skew, and large skew. Then we've got columns talking about who certifies it, who is it certified, who typically certifies it, who annotates it, and then what kind of coordination items. So the approach panel layout memo needs to be prepared by the bridge designer. Roadway designer needs to coordinate the layout of the L joints and the C joints with the concrete unit. So it's a coordination table. Step 2 in the process is annotating the appropriate layout sheet. So you grab one of these first 5 sheets based on your skew and you annotate it. Is step 2. Step 3, you select the appropriate reinforcing sheet. Step 4, you drop any sheet that's not needed. And step 5, you annotate the sheet with project numbers and sheet numbers, and you're done. We have a discussion about end work products that we're trying to put together bid documents for the contractors to clearly understand. And so our approach panels have basically two pay items are typical. The expansion joint, which has been an E8 in the past, and the approach panel itself, which is paid for in the square yard basis. Everything else needs to get picked up, whether it's guardrail, end treatment, surcharge, cover plates, wearing courses in either the bridge quantities or the roadway quantities. And so this section is to help highlight the coordination that's needed between the 2 disciplines. We have a section in here that talks about MnDOT's preferred practices, whether it be drainage, where the joint at the end of the panel is located, how long your barrier should be on your approach panel, and some situations where customized approach panels are needed. There's a section in here with curb and gutter transitions because it's not desirable to have joints in regions that are not same height or prismatic or constant height, if you will. And so what you'll see is that the joints are acceptable in regions that are shaded in yellow or at the very end of the transition. MnDOT does not want to see approach panel joints in the middle of either this first transition or the second transition. And so the first sheet, we've got single slope and parapet here. We've got single slope here. Then we go to parapet and work through the different options as well. So you may be wondering what's included in MnDOT's approach panel pay items. And so we've included the current version as we understand it of the standard that will be out in 2025. And so this is the 2406 section. And so what this will allow you to see is what's expected in the construction of the approach panel. It'll also tell you that the curbs are included, the reinforcement is included in the payment, and the concrete's included, but nothing else. So the medians and the parapets and the guardrails all need to be paid for elsewhere. We've got the standard plans as mentioned before, and so we've highlighted, as I mentioned, what is needed to be annotated to the different sheets, and who annotates it is described in the shading color. And then on the back side of the layout sheet, we have description or notes. And so these are notes to help the designer populate that sheet. And so this is the very first one. And so it's got a lot of notes to help the designer populate the layout sheet here. And so the idea is we've got a sheet that needs some input, and here's some guidance directly behind it. You could print out both sheets and work them together. And so as you go through the skew angles, we've got similar sheets and clouded sections. There's not as much on the back of these sheets because it's covered on the first one. And then we've got more bubbles as we add the square up panels. And so this is sheet 6. And as you can see, the only bubbles are in the bottom right for annotating the sheet numbers and project numbers. The reinforcement sheets are similar in that there's just 2 blue bubbles in the bottom for these small skew sheets, because the reinforcement list is the responsibility of the contractor. We get to the large skew reinforcing sheet, and these are the sheets where the bill of reinforcement needs to be populated by the bridge engineer. He needs to certify it, and it makes sense for him to annotate the title block as well. And here's the sister right-hand skew. And then the last sheet, which just needs to be annotated, is the square up panel reinforcement, which has more notes with it. We then come to the 225 sheets, and we've got just bubbles on the bottom right again. We've got a bunch of notes so people understand how the different sill options should be used. We've got the different options for what terminates on top of the sill. We've got the expansion joint in the sill joint details here on the 226 sheet. We've got the L and C joint layout sheet here. Again, there's just annotation in the bottom right for the 2 blue bubbles. And the drainage sheet that everyone wins for their project. So then we've got the 3 design examples, and I'll just skip through the first 2 real quick here to show you what's in there. We've got a short integral abutment bridge, pre-stressed beams down on Trunk Highway 30. We talk about the sheets that could be used, and then we actually step through and annotate the sheets as they would if it was a real project going forward. So then we've got the notes for how we populated that sheet, and we've got the pay items at the bottom, including the quantities that would be included in the project. We win sheet 6 of 6 because everyone wins that. We've got no skew, so we've got a simple reinforcing sheet. We just annotate the bottom right. In the notes page, it's not needed, but we show people what that reinforcing list would look like if we did populate it. So if you're reviewing a rebar list from a contractor, you've got a little guidance help here. We've got the sill sheet here because we've got sill option C. We need this sheet. We don't need this sheet. We don't need this sheet because we got sill option C. We need to have some joints in our approach panel, so we need that sheet, and we need the drainage sheet, and that's example 1. Example 2's got a sidewalk. It's a little bit longer bridge. We've got an expansion and fixed semi-integral abutments, and we have a sidewalk. So we talk a little bit about how to handle a sidewalk on the approach panel. So here's the 2 different abutments. We've got an expansion and a fixed bearing in the abutments. We've got the profile. We're working in this center section of sheets, the blue column, so we're picking our sheets from there. We annotate the sheet as expected. We modify the transverse section a little bit because we have that sidewalk there. We're going to need additional elevations and stations for the gutter line here, and we'll still present them at the bottom underneath the sidewalk at the barrier as well. So this one had the sidewalk, so we had a little more explaining to do, but we do present the pay items for both the expansion joint and for the panel itself and show how we compute that. Everyone wins sheet 6 of 6. So here's our reinforcement sheet. No need to do anything but annotate it. If you did want to populate it, this is what the populated table would look like. We need the sill sheet. We've got some more information, including what the reinforcement would look like in the sill sheet, because we do have a sill on one end. You don't need this sheet. We do have an E-joint on one end, so we do need to include this sheet. We need to describe the C and the L joints and the drainage sheet, which everyone wins. And then that takes us to design example 3. But before we do that, I want to jump back here and talk about the approach panel layout memo, because this is the bridge audience. And so we'll go into design example 3 a bit more detail here. And so it's a right-hand 45-degree skew. We've got parapet abutments. We've got bituminous pavement. And it's based on Bridge 61006 near Glenwood. And so you can see we've got parapet abutments at both ends of the bridge. We've got expansion joints at both ends of the bridge. It's a pre-stressed I-beam bridge. And so here's our parapet abutment with the end block detail. Our bridge is on a vertical curve. And so we have a number of things that need to be coordinated between the roadway guys and the bridge guys. We talked about that a little bit just a few minutes ago. And so we also need to coordinate, in addition to the pay items, we need to convey the green information to our roadway designers for the bridge. And the vehicle to do that is the approach panel layout memo. And so I'll zoom in here into the 2-page document. And so you can see on the bottom left, both our abutments are labeled as parapet end block abutments. Based on that, the dimension, we've got bituminous pavement, we've got parapet abutments, and our movements are less than 100, our bridge movement length or expansion length is less than 150 feet. So we can use sill option C with no joint at the end of the bridge on each end. And so these are the boxes that would get checked in the approach panel layout memo that gets sent to the roadway guys. In page 2 of the memo, has the stations and elevations for the critical pieces or critical locations on the bridge. So we got left gutter line, we've got center line, right gutter line, got the same skew on both ends. And then we explicitly call out where the barrier should start and end on the approach panel. And so there are only two choices. There used to be a lot of choices, but now there's only two. Either the barriers are 13 feet 4 inches long on the approach panel, or they run the entire length. Because this bridge has relatively long wing walls, the barriers are extended the full length of the approach panel. The designer is saying the quantities for the rebar and concrete for the barrier and the wearing course are going to be included in their plans, and that they will provide sheet 5 of 6 with the 90% roadway plan submittal. And Braden was pretty creative here with his sample names for project manager and regional bridge engineer and design squad leader. So if we go back to our 5-step process, the bridge designer has assembled the approach panel layout memo. Step 1 is for the roadway guys to review the memo and transfer the information to the layout sheet. And so for this particular example, we got a right-hand skew that's more than 15 degrees. And so this is the layout sheet that needs to be annotated. The green information has come to the roadway guy via the memo. And so he adds his information or she adds her information, certifies the sheet, and annotates it. Step 3 is to select the appropriate reinforcing sheet. And because we're over 15 degrees, this needs to be assembled by the bridge designer and certified by him or her. And so we've got the right-hand skew, and so this is the appropriate reinforcing sheet to be used. And so step 4 is to drop the sheets that are not applicable. And since we have type C sill options on both sides, there's no need to have the sill expansion joint details included in the plan set. So add the state, project, and trunk highway numbers to the title blocks. Package it appropriately. It can be labeled in the AP1 through APXX format. Most of these sheets will be annotated by the roadway designer. So then I'll jump back into the document and step through some of the details a little more fully. So inside the guidance document, we've got a few more figures. We've got larger details showing the plan and elevation, the cross section. We've got the abutment type illustrated here. And then we've got profile information so that you can, from this information, generate the stations and elevations of the different critical points on the bridge. We're looking at a skew over 15 degrees, so we're in the gold columns off to the right for the sheets we're looking at. And this is the heaviest lifting that needs to happen for the approach panel design, is to get this sheet annotated. And so the stations and elevations are provided for the different locations. We've got the gutter or barrier to barrier width presented. We've got the out to out length, and we've got check marks and labels for our abutments presented. And then we've got notes for how those numbers were generated. And we've got the quantity of approach panels for the bridge presented here as well. Sheet 6 of 6 is provided because it's just provided. It's a gimme. The reinforcing sheet is the one that the bridge engineer needs to update. Typically, the updates will be in the reinforcing table. And if your skew is large enough and your bridge is wide enough, you may need to lap bars and add bar marks. And so This particular bridge with its skew of 45 degrees was long enough along the skew to exceed the 60-foot length that's typical for bars to be supplied to a site, and so lapped bars are needed. And so those additional bars are presented, and I'll talk about those more later. There is no need to update this drawing to show the barrier going all the way to the end of the approach panel. That information is conveyed on the layout sheet with the stations that show it at this point. And so all that needs to be updated here are callouts if you're lapping bars and updates to the reinforcing list. And so these notes in the example reinforce that. And so in addition to sheet 5 of 6, we've got 6 of 6 to give the details in the square up panel. We have a standard plan included for the sill details because we've got option C. We don't need this sheet because we don't have a sill underneath. We do need this sheet because we've got bituminous pavement coming at the end of our bridge. We do not need the expansion joint for the E8 or E5 joint, and so this sheet can be dropped. We do have the high skew sheet included for the C joints and the L joints. And again, the roadway designer should contact the concrete unit to see if there are updates to this sheet for additional joints. And the last sheet is the drainage sheet. And the document concludes with some of the research projects we looked at when we were putting things together. So if I jump back to the design example or to our PowerPoint, I'm getting there. Just a couple notes about reinforcement and lapping bars. Inside the standard plans, you'll see stagger diagrams for some of the dowel bars that connect the square up panel to the approach panel itself. And that's to distribute where that reinforcement is engaged to help minimize cracking at the start and stop of those bars. And so it should be remembered that number 4 bars can be provided in lengths up to 40 feet typically. Number 5 bars and larger can be provided in lengths up to 60 feet. And so if we dig in a little closer and look at things, we can see that all we needed to do here was to add the lapped bar that we're going to use with the 607E bar. We're going to lap a 617E to it. We got a 604 and the 503 bars. We're going to lap additional bars to those. And all we need to do is update the callouts in the plan view. I apologize, this is a little fuzzier than I expected, but we do need to add the extra bar marks, and there are choices to be made when you provide reinforcing bars that are in the cross section. And so we theoretically could provide all the reinforcement. We could provide a single bar in the 503 or the 604 bars and just have all the splices at the same location. But in an effort to split out those locations and not have all the laps at the same location, we're providing bars of 2 different lengths. We're providing 40-foot standard length bars. We're supplementing those with 22-foot or 23-foot bars, depending on what we need for the laps. And so the additional bars get added into the reinforcing table here, certify the sheet, and annotate the sheet with the project number and the sheet number. So my last topic here, it's 2 o'clock. I know I've been talking a lot. I apologize, but there's a lot to talk about. Last item to give you a taste of is the appendices document. So let me get appendices here. The first appendice is talking about the approach panel layout memos and how to assemble it. So for each of the 3 design examples, a memo is prepared. And so there is design example 1. It talks about a tool MnDOT has in-house, a spreadsheet tool that won't necessarily be available for public consumption, but it gives you an idea on how the different parts of the design are put together for the memo itself. And so here's design example 1, and then it shows you what the layout sheet should look like based on what they've computed here, and it matches what we have in the guidance document. Similar for design example 2, there's instructions on how to assemble the approach panel layout memo. I guess we should say that the approach panel layout memo is going to be considered a standard vehicle for MnDOT work between internal groups. It may not be required by outside consultants, but it's probably a really good checklist to make sure you've got things covered when you're talking to your roadway guys. And so the rest of design example 2 is presented here. Again, it shows how it's annotated. And design example 3 is here. And then we start getting to the row camp goodies. And so Paul put together a nice summary table here, which you'll see on the right and on the following pages. So there are multiple pages telling the approach standards. So you can see when MnDOT went from a single mat of reinforcement to a double mat, when they started tying abutments to the approach panel. He's got a nice summary here. And then every detail standard plan he could round up from 1945 to 2016 is in the rest of this document. So if you're working on a rehab project, it's a wonderful resource, and it should be ready in the next couple days here. I just have figure numbers to add. So I think I've gotten through what I was hoping to get through, Braden. And so, do we take questions?
Yeah, I think we can take some questions. First off, give you a virtual round of applause here. Steve did a lot of work getting this webinar prepared, but also just the guide document and the appendices. You can tell there was a lot of effort involved with that. So thank you, Steve, so much. So yeah, I guess with that, we can probably, if you have a question, just raise your hand, please, and I'll call on you. So Bob Shabaker, looks like your hand was up first. Go ahead.
Early bird gets the worm. So since we couldn't ask questions during the presentation, I've got like 5 things that I'd like to ask about. I'm just wondering, did they fix the 1.5-inch dimension behind the barrier on approach panels to 2 inches to match the edge of deck?
It's still 1.5 inches on the layout sheet, you'll see.
Well, okay.
Yep.
Is there a reason for that, or why don't we want it to match?
Bob, that's 1.5 inches to allow more room for bridges with the approach panel tied to the bridge. It gives it a wider joint along the wing wall so that it can rack a little bit more. So it's not a mistake. It was intentional on the previous, and it's intentional on this version as well.
Perfect. The Davidson joint, I'm just wondering if we can't get another checkbox on there for plow fingers. And then how does the Davidson joint and the expansion joint and the plow fingers intermingle?
I'm not sure why that, I mean, that's more of a bridge plan item than an approach panel item, right?
Well, we never know if we need plow fingers or not because all the districts kind of do their own thing.
Don't put plow straps on E8 joints.
I'm not talking about the E8 joint. I'm talking about the expansion joint at the deck.
That should be, I think the approach panel plans isn't necessarily the right place for those plow fingers to go. It should be
So
in the
where
bridge
do we
plans.
where do we find out if we have plow fingers on the bridge?
There's a table on the standard plan for expansion joints that details all the set down dimensions you need from top of deck and whether or not you need plow fingers based on skew.
Yep.
Okay.
It's in a bubble designer note on the standard expansion joint plans.
Skip that one. And then in the past, we used to use parallel bars on the approach panel side of the expansion joint. Are we continuing that? It doesn't look like that from the details. It looks like they just get spaced at 6 inches and then at 1 foot.
Sorry, can you repeat that question? I'm trying to visualize what you're talking about here.
So, you know, when we do our section through our expansion joint, we got 4 extra bars on the deck side and 4 extra bars on the approach panel side. Are we still doing that? They're kind of intermingled in the expansion joint device.
Oh, yeah. So basically, yeah, the end block option in the end block itself, you would show the reinforcement there because that's part of your bridge. But then the additional rebar in the Davidson should already be included in in that detail that Steve's highlighting right there. So you wouldn't include that reinforcement in your bridge plans. It should be in the approach panel plans because it's already paid for and detailed there.
Okay, good. And then I don't know if I missed it, but we used to have a 20-foot option versus a 15-foot option when you got a highly skewed bridge for the approach panel length. Do we still have that? I didn't see it when we were going through.
Really just kind of 20 foot is the preferred. And I think that's really just to help with the differential, settlement, ensuring more of a smooth.
So it's always
surface.
20 foot.
Yeah, I mean,
No,
I know
there's
there
a
might
note,
be
Steve. Don't remember if Steve covered it or not on the minimum absolute length. There it is.
Okay, there it is. I must have missed it.
perpendicular.
Perfect.
Yeah, sorry. Yep.
And then what was this one?
That's 15.
Oh, on the bars.
Perpendicular to the skew. Yeah.
The bars. Steve was saying to use 40-foot bars on the approach panel. We can use a maximum of 60-foot number 4s for deck or slab bars. Wouldn't the approach panel be treated the same as a deck, or is that not true?
The issue, the whole reason for that 40-foot limit for the smaller bars is that if you're picking them up in their smaller bundles, they tend to deflect a lot. And so if there's large bundles, I think the BDM allows you to go above it, but we decided just sticking with the 40-foot for the number 4 bars, I think.
On approach panels.
Yep.
But not decks.
Because decks, you would be ordering a lot of them.
Okay. All right, that's it. Thank you.
Paul Stenberg.
I had a project that had a sidewalk on there. Could you expand on, I was talking with Braden about, who's paying for it and where is it included? I didn't really see any discussion of that. But now it's all going to be kind of like barrier included in the bridge prices, bridge quantities and stuff instead of at the end of the expansion joint. We used to just throw it onto the approach panel.
The concrete and the reinforcement for the sidewalk, the payment and detailing of that is included in the bridge plans. And I think that we're providing some guidance in the memo. If you go to the memo, we have a little, basically all the stuff in red in that memo is, you can enter data field basically. So you can throw in anything else there. But yeah, we're treating it similar to what we do for barriers, where the concrete and the reinforcement that extends onto the approach panel is included in the bridge plans. So same thing with,
I see that in that paragraph now down there. Third one or second one up from the bottom there on the right-hand side.
Mm-hmm.
Okay, that's all I had. Thank you.
Jisha.
And as engineer back in the 1990 to 2003, in the DAC, we had a problem with the pavement growth to push into the approach panel. So at that time, we made the changes to put the EA joint between the first and second panel of the pavement, not next to the approach panel. So I don't know. Now we were the back between the approach panel and the first panel of the pavement. So what kind of decision to make this change back and why and any reason?
Are you saying for sill detail option C?
Yeah, in the past, if you go back to 2000, after 2003, the the seal, the 2-foot wide seal, 2 or 3 foot wide seal, and by 1 foot thick, that one for the E8 joint or E5 joint.
Yep.
At that time, I pushed back to the between the first and second pavement panels, not next to the approach panels. I don't know what's going on with it. Oh, do you remember why?
That's not a recent change, Jisha. I don't remember. Are you confusing it with when we had lugs in the first panel off the end of the approach panel? Those have been
Yeah,
removed
if
when
you
we
go
went.
if you go to the 2003 and around that era, the standards, I made the changes to put the lead into first, not at the end of approach panel.
So it looks like Steve is going to go to the handy dandy history document here.
It's about 2000, 2001.
I do not recall the sill being at that location, Jisha, but that's more than 20 years ago. So
Yeah, I did the changes.
see what Steve finds.
So in the meantime, I got a question from an inspector about why we put plastic everywhere under the approach panels. And I just said, it's just a default thing to improve the sliding of the approach panel, even though you might have a parapet abutment. But I'm just wondering if anybody knows a better reason.
That's what it's from, Paul. That was from neighboring states who had integral abutment bridges before we did. They all used plastic.
Oh,
as a
now I
bond break.
recall. I'm sorry. Those kind of like shear. Those
The pavement
you see
lugs,
it?
Jisha, yeah.
Yeah,
Yeah.
yeah, pavement lug. I moved over it. Is that still true?
No, because those were problematic when we went to integral and semi-integral abutment bridges and the approach panel moved. They were getting constructed incorrectly. So there is a pavement. I forget what there's a detail that will now go onto the roadway side, I should say, with the lugs, but it's been removed from the approach panels because it's not on the approach panel. It's a roadway detail.
Yeah, those are those of it. Okay, it's been a while. I forgot.
All right.
Details.
So
Sorry.
Paul, back
Thank
to
you.
your question, it was for trying to reduce the friction and allow movement on integral and semi-integral abutment bridges. And then the concern we have, if you take it out for parapet, well, it just doesn't translate through on construction. And so we end up with no plastic on the bridges we want it and plastic where we don't. And so
that's what I thought. So I guess,
cheap
but I thought there
insurance.
might be also some benefit during rain events to keep the rebar clean if it splashes up off the dirt or whatnot. But
Primary reason was for friction.
Okay. And then was there any discussion about fiber wrapping the fill underneath the sill? I can't remember if we said, let's just not incorporate that at this time.
So
like geotextile layers.
District 7 has been using a wrap in the entire embankment fill. And when Terry Baudry and Joe Neatfelt from the geotech section took a look, their performance was not any better than unwrapped sections. So at this point, we haven't moved to make that change, but realize that's independent of the approach panels because those would be the approach treatment sheets. So not to say that those can't change, but they would not be indicated on these sheets. They would be indicated on the approach treatment sheets.
So
Some
I
of
saw
which
that
are included in the history document there. You
I
can
saw
see.
that Andrew Lover did the research on this for his master degree. Andrew, are you here? Andrew Lover.
Yes, what's the question?
Yeah. I remember when you were in Arlen's unit, Kevin West asked you to look into the geofabric or geogrid behind the apartment underneath approach panel to do some improvement. When I was the standards trying to do something to improve the performance of the backfield behind the apartment underneath
Yeah,
the approach panel.
yeah, I mean, coming from District 7, we're very happy with the way that we do our abutment backfill. It's got really nothing to do with the approach panel sheets. And so I'm not sure if it's a conversation for this meeting.
Okay.
But we really like it. The main reason is not anything that the fabric does, but what it does is it makes the contractor put in the backfill at the specific layers. And so they're not able to just have the inspector go to lunch and then they fill in the back of the abutment and then it's done. They need to do each layer, and that makes them take the time and it makes them compact each layer. And so that's the main benefit. It's not anything that the actual fabric is doing, but the fabric is so cheap and it's such an easy way for our construction inspectors to make them put in the backfill and the compactive effort that they need to. But again, it's really got nothing to do with the approach panel sheets.
Okay. Thank you.
Paul Stenberg, you got your hand raised.
Yeah, right now I have 2 bridges going up in District 1 near Eveleth, and it has bituminous roadway on one side, concrete on the other side. On the bituminous side, they're having their roadway guy. They have these new standards and everything, and I've worked with them on them. But are you guys aware that they're modifying your option C sill?
Yep. I've been wait. I mean, that's their option if they want to modify from the standard. I know that they're adding a sill below the sill option C, and that's not what's on our standard. So it's kind of their own risk. But we will look into it. But I'm aware that that is happening. Yes.
Yeah. So they're having the roadway guy is having to modify that himself. So anyway.
Yep. Justin Zimmerman, go ahead.
Yeah, it's kind of a quick question with regard to the E8 joint. I had sort of hoped that maybe there'd be some guidance or improvement on an option that might have a little better longevity. It seems like sometimes they don't last so long. Is there kind of anything in the works as far as a successor to that might have a little better long-term performance?
I guess I'm curious where your concerns have come from. Have you heard from maintenance or who's been having issues with the E8s?
We had one down here in Rochester. We did, and it only lasted like 6 months or so. And I was looking into what to do to recommend to the city, and actually found this MnDOT document titled "Synthesis of Bridge Approach Panels Best Practice" from 2013. And right in the executive summary, they were saying that it joint hasn't performed well, often failing within 1 year of service, which is kind of our experience. So it could be perhaps some susceptibility to installation procedures and all that, but just curious if there's something that was being developed as a little more durable, maybe.
Sure. I thought relatively recently they tried out a whole bunch of different E8 joint materials down. I forget where that was, kind of South Metro-ish. Mark Spafford, I don't know if
Andrew wants to jump in, Braden.
Oh, go ahead, Andrew.
Yeah, if that's okay. Yeah, we've had some very frustrating experiences with some E8 joints down in D7. Just our bridge crews going back after a year or two and just having them disintegrate, or having them not connected and having them either float out or drop down. We met with our construction staff, and one of the brand name was, or what type it was, and what the instructions for installation were, right? And so how are our construction inspectors able to inspect something and make sure that it's done according to the manufacturer's instructions if they don't even have those instructions? And so we've done a few things in our D7 plan notes. We just created a plan sheet and we put it in there for all of our E8 joints. And it says, you know, contractor, you must send the manufacturer's instruction notes to the project engineer 3 days before installation. And so there's also a pre-activity meeting where we meet with the manufacturer's instructions with temperature and sandblasting and all the different things that our bridge crews would do, but we found out weren't being done during construction. The other thing that we put in there is a 28-day cure, because some of those chemicals and some of those adhesives aren't working very well when that concrete is curing. And so those are some of the things that we've been doing in D7 to try and get a better product out of those E8 joint installations by our contractors. Does that help?
Yeah, thank you. That's very helpful. I think some of the stuff you described is what exactly we had going on. It felt like the contractor was a bit clueless on how to install it, and we didn't have a whole lot of previous experience with them, so it's a little hard to hold their feet on the fire as far as how to do it right when we didn't really know. And then
Yep. And one of the other issues is temperature. Sometimes these E8 joints are showing up a week or two before they're installed. It's late in the season. It's kind of the last thing that gets put in. And so they could have been at like 32 or 35 degrees. And if the manufacturer's instructions are saying it needs to be put in at 55 degrees, well, contractor, how are you going to do that? You can't just pick it up out of the ditch when it was 35 degrees last night and then put it in and then expect these chemicals to work. And so step one is to make that contractor send those manufacturer instructions to the construction inspectors. And then that's our first step in getting these things installed correctly. Mark, you've got your hand up.
Yeah, so Braden had mentioned my name. Real quickly, 2012, Dwayne People and his team, maintenance supervisor, we installed a number of using and tar on the Fairbolt main line. And I guess I was just talking to Dwayne about this a couple of weeks ago. We feel that it's probably more for Justin, the Wabo Genie joint and the DS Brown JP are both neoprene glands, and we would put those at the top of the list, but we don't put things at the top of the list on the APL. But inside knowledge, those would be at the top. The V-Seal and the Silicoflex joints would be our next choice. And it's totally 100% dependent on prep.
Exactly.
And the age of the concrete. If they use an epoxy doesn't like moisture, so it's not going to hold. They're going to float out. Getting a drainage tile in there is going to be really, really beneficial. And to make sure that it gets 3/4 of an inch to an inch below the roadway surface, so it doesn't get the tire slap. So just a couple of quick comments there, Braden.
All good points, Mark. Thanks.
Thank you. Any other questions?
I had a couple in the chat, Braden. I don't know if you want to.
You want to just rephrase them here?
Well, yeah. So quite a few of you on there are going to know the how the nomenclature originally started back in history, where it was the width of the joint divided by 2. And I was asking if the stakeholders had discussed getting rid of that, because it's confusing for people in the field. You call out an E8 joint, but then you tell them it's 4 inches. So just wondering if that had crossed the table at all, because I know the concrete office and I have talked about this, because I maintain the APL for them.
Mark, I recall the group did talk about it, but Jake was our representative and visited with Maria, and when all said and done, obviously it didn't change. It stayed, because we actually developed the E5, and it was, based on the 2.5 times 2. So it was discussed, and obviously no change was made.
Okay, my second question then was about the perforated drainage tube. It continues to be a question that comes into the construction unit of where are we supposed to get that product, and what is actually called out on the standard sheets now?
Yeah, we'll have to circle back. Terry Beaudry owns that list and that discussion. And so I know, I can't remember if we even have a special provision now or how we've handled that. I forget, but APL might be difficult because as I recall, there's only one supplier. But we can chat offline with Braden about that. It was discussed there. I don't believe there is an APL and it might be difficult to generate one, but we can chat offline.
Thanks.
Lindsay Lawrence, you asked if an approach panel layout memo template would be made available online. If so, where would it be located? I guess we hadn't considered that. We were going to provide it to, well, the internal MnDOT folks do have access to it. And I know ComSci is working on, we're going to be publishing these 2 webinars, the guide document, the appendix, all online. I suppose we could throw the memo up there as well. I guess the caveat being, it's the way it's written is it's more coming from a MnDOT person, but it's certainly, I mean, the template's going to be up there regardless in the PDF that is in the guidance document. But so, and I think that website, I think there's still some IT issues that we're having from that global outage a couple weeks ago. So things are moving a little slow right now, and that's just the nature of it. But I think we will be sending out or ComSci will be sending out the Gov delivery notification when the website's all ready with these documents. Any more questions? Hearing or seeing none. Really, thank you again, Steve. This was great. I will be posting this recording again, like I said, to the website. So stay tuned for that. But appreciate you all showing up, and thank you again, Steve. This was great.
Okay.